The subject of this video is mineral hardness. Hardness has been used by geologists for a long time to be able to distinguish not only individual minerals, but different varieties of minerals. It's one of those properties that, when measured correctly, can give you almost absolute interpretations for what a mineral is. Unfortunately, the way to actually do that requires quite a lot of high technology. I remember when I was a student at university, we had a device for measuring mineral hardness. And what it was a kind of like an anvil press, a very small one, that had a diamond on the end of it. And what you would do is you put a specific weight on the diamond and have it come in contact with the mineral. And then you'd look to see how big the depression was in the mineral, and you'd measure the width of it. And if you knew what the amount of weight was that was added to the width of the impression, then you could get a quantified number. Now, most universities, and certainly very few high schools or middle schools, if any, have that type of technology to be able to measure mineral hardness exactly. But over the years, actually over the centuries, geologists have come up with very quick ways to get an idea how hard a mineral is. Now, the first diagram I want to talk about is this diagram. This, of course, is the Mohs hardness scale, and it was proposed by a geologist by the name of Mohs, hence his name. And what it did was it looked at 10 common minerals. And when I say common, I don't necessarily mean you find them lying around everywhere. They're just minerals that most geologists had access to in a lab at the time. And what Mohs did was to take those 10 minerals and arrange them in order of increasing hardness. So on this list, you'll see talc is the softest of the common minerals. Gypsum followed, calcite, fluorite, apatite, orthoclase, which is a type of feldspar, quartz, topaz, corundum, and then finally diamond. Now, diamond is the hardest substance that we have found in nature at this time. But here's the thing. Mohs hardness scale does not give an absolute hardness of a mineral. All it does is rank them in terms of increasing hardness. If you looked at the absolute hardness, this diagram shows us here, and by the way, this, as well as the previous diagram, are modified versions of the diagrams that are in the minerals guide that's on the CD. What it shows you is the absolute hardness of minerals relative to one another. So you can see talc, mineral number 1 on Mohs hardness scale, is the softest, and diamond is the hardest. But look at the transition as you go from corundum up to diamond. Diamond is much, much harder, relatively speaking, than corundum, which is harder than topaz, etc. So absolute measurements of hardness is something that is going to be kind of difficult to do in outside of a laboratory setting. Now, going back to this diagram for a second, you'll see that not only are the minerals arranged according to hardness, but we've added some common materials that people would have that would allow them to very quickly distinguish hardness. For example, a fingernail, provided your fingernails are normal fingernails and not chewed to death, I tend to do that an awful lot, so my fingernails tend to be softer, have a hardness, relatively speaking, of 2.5. A copper penny, such as here, has a hardness around 3.5. Now, a word of caution on this, okay? Pennies are probably one of the worst things to use for determining hardness. It's because new pennies, and I hope you can see the difference between these two. It's kind of hard with the lighting in through here. This is a new penny made since about the 1990s. This is an older one, pre-1990. You'll see it's tarnished. This one's not. That's because the new pennies have aluminum in them, and their hardness is significantly less than 3.5. So really, when it comes down to it, in terms of pennies, toss them. They're totally useless. But what you could use to determine hardness very quickly is a piece of glass and something metallic. Now, in a previous video, I showed a knife for determining or being able to scratch minerals. And I think I said in that video that's probably not the wisest thing to be advertising in the school, but anything that's made of metal, a hard metal like a screwdriver, is perfectly suited for determining mineral hardness. Now at this point, I'm going to turn to one of the instructional videos, again starring Zach this time around, to show you how to use glass to determine mineral hardness. Now he's got a very big piece of glass. It doesn't have to be that big. Yeah, big smile, Zach. It can be a smaller piece or anything you have. Just be careful, there will be sharp edges. This is tempered glass, so it's a lot softer. Here he is demonstrating Graphite, as you can see, graphite is too soft to scratch glass. If you recall, graphite was one of the minerals that marks hands. Your hand has a hardness of around 1.5. So the fact that you can scratch graphite in your hands, or in this case, talc on your hands, gives you an idea that the mineral itself has to be softer than about 1.5. In fact, talc has a soapy feel because basically you're rubbing it off onto your hand. So very soft minerals. If you pick up a mineral like calcite, calcite has a hardness of 3 in the Mohs hardness scale. Again, will not scratch glass, but also will not scratch your hand because it is harder than your hand is going to be. Your fingernail has a hardness around 2.5. It will not scratch calcite because calcite is harder. This is a very large sheet of gypsum. You have a gypsum sample in your kits. Here you can see, well, you can barely see, but Zach is able to scratch the gypsum with his fingernail because, again, it is softer than his fingernail, a hardness of 2. Now, this is quartz. Quartz is a harder material than glass, and it will scratch glass, although it's going to be very difficult to see here simply because of the nature of the video. Okay, now I'm going to try and emulate a little bit what Zach was doing, because when you're shooting something on a large piece of glass like that, you can't really see as clearly as you would like to. So I'm going to demonstrate this, and hopefully this will show up. Piece of glass, and here's the graphite, and I have to do this very close to my face so you can see this and all. If you scratch on here, nothing's going to happen. Sometimes you will see a mark left on the glass, but if it does not show up as a scratched glass, sometimes it's the mineral actually rubbing itself onto the glass. That's exactly what happened with the graphite here. Talc's the same way. Whoops, that's not talc. Talc's the same way. I hope you can see there's actually what looks like scratching on the glass. That's not scratching, that's actually the remnant of the talc actually on the glass. Okay. Now for a harder material, say quartz, this is quartz here now, if you scratch the glass, hopefully you can see that it's left a nice little mark on that. You have to sometimes use a lot of force. If you just touch it lightly like this, you're not going to scratch anything because you're not giving enough force to do it. So you have someone to get in there really hard and do it. And incidentally, something like chert, this is how you would identify how chert, or what chert is microcrystalline quartz. It will also scratch glass because these two materials are essentially the same materials. One is just not crystalline, this one is. And lastly, again, in demonstration, fingernails, if they're not chewed, if you take a mineral like gypsum, it will scratch quite easily. Hardness 2.5, hardness less than 2.5. That's all you need to know really about mineral hardness.